So we work on solve activity number 13 here for linear approximation. The first thing we say is we want to find the equation of the normal line and the normal with the tangent line of the function that's already given to you. It's quite obvious. It tells you the tangent line at the point is having a slope of 3. So what is a normal line? Normal line is something that's perpendicular to your tangent line. So this is your tangent line at the point 1, 2, then the normal line is something that goes like that and it's perpendicular to that. So all you need to find is what exactly is the slope with the point which is actually already given. The slope of your line is negative reciprocal of the tangent line. So it's literally take this number and take the negative reciprocal of that. So your final answer is y minus 2 equals negative 1/3 x minus 1. So this is the equation of the normal line. But let's go back to our regular business. We want to find linear approximation. So we want to find the equation for the linear approximation at the same point. But we did say tangent line and a linear approximation, they are essentially the same thing. So if y plus 3 is 3x plus 2, where we know that y is roughly speaking your function value, or your linear approximation. So essentially what you are telling me is that my linear approximation or my function is roughly speaking negative 3 plus 3x plus 2. It's literally just whatever you had as a tangent line. Keep only the term y on the left, and that's your approximation line. So your f of x is roughly speaking 3x minus 1, and that's the end of it. So use linear approximation to find the value estimated at the point with input of 0.9. So that is to say you have 3 times 0.9 minus 1, which is 2.7 minus 1, which is 1.7. Okay, so this is what we end up with as the answers. So keep going. The first thing I want you to use your calculator to evaluate the function value. Hopefully the first one is at least easy. It's cosine of 0, which is 1, times e to the 0, which is 1, divided by 0 plus 1, which is 1. So the first one is 1 times 1 divided by 1, which is 1. Second one is slightly more challenging. I do encourage you to take out your calculator to do the evaluation. Right? Okay, so what we want to do is to find the linear approximation of the function at the point of 0. So you know that you are trying to build the equation of a tangent line at the point of 0. So that is to say you need to know what's f of 0, which you found in the previous problem. You want to know what's the derivative, which you are going to use quotient rule as the first step because it's technically division. So you have cosine of 2x times e to the x takes derivative times x plus 1 minus cosine of 2x times e to the x multiplied by x1 plus 1 takes derivative over x plus 1 squared. So when you try to take derivative of this term, you realize that definitely is going to be a product rule because it's a multiplication. So you end up with cosine of 2x times the derivative times e to the x, and then add to cosine of 2x times e to the x takes derivative. But keep in mind, this is only rephrasing that term. Everything else that's left, you need to copy-paste the structure. So multiply x plus 1 minus cosine of 2x times e to the x times 1, because derivative of x plus 1 is trivial, divided by x plus 1 squared. So you continue your calculation. You want to find out what's e to the x prime, what's cosine of 2x prime. You can do it on the side. If you are very familiar with the process, you might be able to find it in your mind already. Cosine of 2x gives you negative sign with 2x substituted in, multiplied by the derivative 2x, which gives you 2. Right? Again, similar idea. You are expected to follow the structure. So this term, change into that. You copy-paste what's left. It's e to the x plus cosine of 2x, and then multiply the derivative of e to the x itself, and then just copy-paste the rest part of your structure. So what you end up with is this whole thing multiply x plus 1, and then minus cosine of 2x times e to the x, and then whatever that is divided by x plus 1 squared. Your concern is not what's the derivative, it's what's the derivative when the input is 0. So you plug 0 into your structure, what you end up with is negative sign of 0, which is 0, times 2 times e to the 0, which is 1, plus cosine 0, which is 1, times e to the 0, which is 1, multiplied by 0 plus 1 minus cosine 0, which is 1, and then e to the 0, which is 1, and then divided by 0 plus 1 squared, which is 1. So what you end up with is 1 times 1 minus 1 times 1 over 1, which is 0. So you did find out that the derivative, which is this term, is technically 0. You have your function value, so all you need to do is plug everything back in. So the linear approximation, if you want, f of x is roughly speaking f of 0, which is 1, plus f prime of 0, which is 0, times x minus 0. In other words, it is simply 1. So when your function, which looks extremely complicated, the function's behavior is roughly speaking just like a horizontal function with a height of 1 near the point of x being 0. And therefore, if you want to find out what's f of 0.01 for a constant function, there's nothing to change. So you simply find this. So f prime of 0.01 is simply going to be 1. Well, if you had plugged things into your function, you should have find this value already, and then you can find the difference quite easily. I will plug those numbers in once I get my calculator. So let's move on the last two problems, which again quite simple. So first of all, you have your function as f of x being square root of x. You want to find out what's the function's behavior around the point 9.01 by doing linear approximation. So what you want to have is something, I directly tell you the answer, it's supposed to be 9. I choose this number 9 because first of all, f of 9 is easy to evaluate because it's quite obvious square root of 9 3. The second thing I have is that 9 is close to 9.01. So it definitely doesn't make sense if you were to approximate the behavior function at this point by choosing a special point at, let's say, 900. So you want to be as close as possible. So that's why I choose my A as 9. And by doing this, all I need to do is to find my linear approximation, which is roughly speaking f of 9 plus f prime of 9 times x minus 9, where f of 9 is root 9, which is 3. F prime of x is the derivative of x 1/2. It's 1/2 x to the negative 1/2. It's 1 over 2 root x. Hence, f prime of 9 is 1/2 root 9, which is 1 over 6. That is to say, it is 3 plus 1 over 6 x minus 9. Hence, f of 9.1. Don't forget, okay, whatever you have to evaluate, plug in, is whatever was plugged into your function. I know you were asked to evaluate this, but what's actually squeezed into the function, if you compare, you are trying to find f of 9.1, okay, f of 9.1, not f of square root of 9.1. If you are looking for f of square root of 9.1, according to the definition, you are talking about what's the value of this, which is 9.1 to the power of 1/4, okay? You shouldn't be approximate your function by square root anymore. You should have a 4/4 root to approximate it. So be super careful about that. Don't literally take whatever was given to you. Be a little bit careful. What's the input? What's the function? Put two parts together, right? So the next thing you have is 3 plus 1 over 9. 9.1 minus 9, which is 3 plus 0.1 over 9. You could have done the approximation if you wanted to, so it's 3.0, right? And then you have 1 and 6, 7, something like that. So this is my approximation. And I'm going to do something similar. In this case, it's actually more challenging. I only give you one structure. I didn't, you may realize or you may not, so I want you to be able to realize it yourself. This technically is evaluate what's going on with the function f e to the x, where x is 0.01. So you need to choose a point that's close enough to do the approximation, and then you need to figure out what the function is like. So in short, what you are trying to do is find out what's f of 0.01 given f of x being e to the x, x being 0.01, and you want to do the estimation at the point of 0 because it's close enough. So all you need to do is to put everything back together. F of 0 is e to the 0, which is 1. F prime of 0, f prime of x is quite easy. It's e to the x. So it's e to the 0, which is 1, right? because f prime of x is e to the x. So I can find my linear approximation function quite easily, which is 1 plus 1 times x minus 0, which is 1 plus x. Hence, f of 0.01 is 1 plus 0.01, which is 1.01. So that's my final answer. Again, be super careful. When you try to plug the number in, don't literally take whatever was given to you. Put it in the context of your function. If your function were e to the x and you want to evaluate e to the 0.01, you meant to say x is 0.01, right? You don't mean to say x is e to the 0.01. So be a little bit careful with that.